We're on the first lesson of Chapter 9, which is scatter plots. First, we're going to describe correlation from scatter plots. Then we're going to use a scatter plot to make predictions. First, what is a scatter plot? Well, a scatter plot is a graph with points plotted to show a relationship between two sets of data. And I guess this is the main point, it's going to show a relationship. So if we have a data set over here and a data set over here, a scatter plot would show whether there's a relationship between those two sets of data, or the word we're using today is going to be correlation. A correlation describes a relationship between two data sets. The first correlation we'll look at would be positive correlation. In positive correlation, both data sets increase together, meaning as this one increases, you'll notice that this one's increasing by going up. And that's happening over here as well, except this one's a little bit stronger than this one. If you notice, if we drew a line in the direction this one's going, a lot of these dots are really close to that line. If we did that over here, this one is still following that general pattern, but we have some ones that stray a little more than this one, making it a little bit of a weaker correlation. Over on the right side, we have negative correlation, and that means as one data set increases, the other one's decreasing. I know I've shared this relationship with you before, but if you measure number of TV hours watched in a week per child and reading scores, you'll notice as one goes up, as TV watching goes up, reading scores typically go down. And that's the idea. And sometimes when you measure these two data sets, one's going to be a really strong negative, meaning that it's really going to follow this line, and some are going to be a little more weak, meaning that they're going to stray a little more. Finally, there's no correlation, and that means that the changes in one data set have no effect on the other data set. It's just going to be dots scattered all along this plot. So let's create our own scatter plot. It says the table shows the winning times for the Olympic women's 3,000 meter speed skating race. Use the given data to make a scatter plot and describe the correlation. So if years since 1976 becomes my x-axis down here, what scale would I use? Well, I see it's anywhere from 4 to 30, so I could probably start at 0 for x. And since I see that it's counting up by 4s and going all the way to 30, I probably could count by 8s here and get all the way to 32, and that would work out pretty well. I notice that the lowest winning time is 3.96. So what I'm going to do here is I'm actually going to skip all the way to 3.5. And you can show that by making kind of a symbol that looks like that. And then this symbol here would be 3.5. Skip 2 to 4.0. Skip 2 more to 4.5. And since that's 4.54, we'll just leave it at that. Now let's plot our points. So 4 years after 1976, it's going to be 4.54, so right about there. 8 years after, at 8 years is 4.41, so 4.41. 12 years is 4.20, so right about there. 16 years is 4.33. 18 years is 4.29. 22 years is 4.12. 26 years is 3.96. And then 30 years is 4.04. So now I have plotted out all these different dots on the scatter plot. Now we need to describe a correlation, and I'm going to do this verbally since it takes a lot to write onto here. I do notice that it's going down as we're going to the right. So that means as one goes up, the other one goes down, making that a negative correlation. Now is this going to be a strong or a weak one? Well, I notice that if I draw a line here, it actually, most of them stay really close to this correlation. And I would say that makes it a strong correlation. Now we can use a scatter plot to make predictions. It says make a scatter plot of the data and draw a line of best fit. Then use the data to predict the exam grade of a student who studies 4 hours per week. So this is the relationship between hours studied and the exam grade. So we'll make hours studied our x-axis, and I see that the highest number is 12. So this actually does have 12 boxes, so I could just count by 1s. We'll just count by 2s actually here, every 2 boxes. Then our y-axis. Then the lowest y-axis number is actually 70. So what I'm going to do, we're going to have 0 down here, and we're going to do that symbol again and have 70. So I can probably just count by 10s here to make sure we get there. And this doesn't have to be exact. You actually could do this differently than me, and you're still going to get the same idea. So we have someone who studied 5 hours, and they got an exam grade of 80. Someone studied 9 hours, and they got an exam grade of 95. So 9 and 95. Someone studied 3 and got a grade of 75. 12 hours gave someone a 98. 1 hour gave someone a 70. 2 hours got someone a 95. 6 hours gave someone an 82. And 7 hours gave someone an 88. So overall, I do see a correlation, and it's going to be a positive correlation. As this goes up, this also goes up. And I would also call this a strong positive correlation, seeing that all of them except for this random one over here, who didn't study too much but still got a good grade. This does follow a pattern that if you study more, you get better grades. And this is what they mean by using the data to predict someone who studies for 4 hours per week. We could try to draw a line that'll fit this data really well. So try to kind of split it in half, usually what you try to do. And when you do that, you can usually predict pretty well what someone along this line will get based on how they studied, especially when it's a strong correlation. So when someone studies for 4 hours, what do they get? 4 hours would get them, we would say, about a 78 on their exam. So you would say 4 hours would be about a 78%.